So less people today. Yeah, am I audible? I need to configure my recording. Sorry about delay. I was in a meeting. Yeah. So last class. What did we discuss in last class? Assignments, right? Am I audible? Okay. So we discussed assignments. So till week 4 we discussed, right? Okay. So let me share my screen. Is my screen visible? So week 6 is live, guys. We might have studied week 6. We started studying week 6. Deadline is 26th. So anyways, I'll discuss this assignment in conceptual level. On conceptual level, I will not be discussing solutions for it. But I'll discuss last week's assignment, last year's assignment. For the same subject. Week 4 we can discuss it. Week 4 assignment for solutions. So by the way, any doubts till now in week 4 assignment? Say any in any course level doubts? Okay, please go ahead. Not enough input arguments. So what happens is when you run some code, you have, if the code is written in such a way, it requires some inputs to be fed alongside the command to run the code. It needs that, otherwise when it traverses those commands, it will not be able to find them. And what happens is, it cannot basically use those values passed in the command in, say, in computation, whatever it wants to do. So that's why you have to check whether you are passing the exact command to run the code or not. Okay, I'll do it for you here only. Okay. Which week code was that? Let me run it for 4th week. Okay. I mean, this is the last year's course, but the code will be the same. Where's the code? Hello? Okay. So, guide me through. Okay, I'm not a MATLAB user, so I will help you run the code, but just let me know how to run the code. Where are you running it? MATLAB website. MATLAB run code. Okay. I don't know how do we run it. Okay. I don't have the key as well, so you might have to help me with that also. Okay. This one, MATLAB Access. Okay, I'm doing it with you. Just wait, let me do it. So those who are facing problems in MATLAB, I'm doing it on one side. Just keep so I didn't let me use it for free. Okay, let me use it for free. 20 hours a month. I don't think so. We need 20 hours. We have the course remaining for like 8 to 16 hours max. Okay, so I have the code. Let me load the module. Week 4. Let me go to week 4. So these all codes are there. Let me download this, download this, download this. From where do you upload the wait, I got it. I have this script, I have pasted it here. I'm saving it as file1.matlab, okay? Now I have to run this code, right? So let me run it. Unrecognized variable model. Acha, it requires all 3 files, I think. How do you upload it? Totally drag and drop. this main model. Okay, and this is the file. This is main model. These are the same files. Okay, now let me run this file. Okay, it should again give me some. Yeah, it's working fine. What? See, it's trying to fit the data, the straight line data. And something is happening. I don't know what something is happening. Okay, I can. Yeah, but it's not converging anyways. Let me just put this file as well. Final regression simple. Regression simple. Am I audible? Let me run regression simple file, okay? Yeah, this is something. See, now this data is interesting, and see the line fit. It's slowly moving upwards, okay? And slowly this thing also come down. It will take some time. While error is greater than EP should be some value. EP is 10 raised to power minus 3. See, it's working for me. What's the issue with your code? Can you run the code right now to show me? Anybody else who is facing MATLAB issues? Okay, apart from MATLAB, is Python code also given to you, right? So what you can do is you can try doing Python code if the MATLAB is causing problem. Okay. So if there's a serious concern regarding MATLAB code not working, so you can use Python code. Otherwise, I'm there to help you on it. Okay, if it doesn't work, just share the screenshot on email. Okay, on that discussion forum, and just leave it there. Share the screenshot, whatever issue you are facing, share the screenshot and leave it there, and next week we will sit and see. Okay, or if you can just do it, like if you can mute yourself and go away and check for 5-10 minutes if it takes some time like that, and you can check and you can come back. That will also work. Got it? Hello. Okay. So yeah, anybody else? Any doubts in running the code? The basics of this course. If there are any doubts in that, just let me know, I'll help you out. You can unmute yourself. Yeah. Which one? Which question? This. Acha, we haven't discussed assignment 4. Okay, we'll discuss assignment 4 also. Linear models. Okay. Just a second. Let me open last week's assignment 4 also. Last year's assignment 4. Okay, yeah, this one we have discussed. This one will happen. Okay. Yeah. What is the problem? You're not audible here. This one is correct, right? This C option. Linear model, suppose the Ross function is given where x is design matrix, where what is x? Where is x? Y dash is prediction model vector, y is the output, w is given, expression for optimal value of w will be, yeah, see, it looks confusing, it should not be confusing. You might have felt like, sorry, no, it's a regularization parameter, it's not eigenvalue, it's just a regularization parameter, it's given, right? Had it been an eigenvalue, it would have been given to you. Yeah, I think fourth option should be correct as per you, and I also feel that, but my iPad is down, let it charge for some time and then I'll discuss. Anyways, let me write it on paper and then I can show you. Lambda, in this thing, I think lambda is eigenvector only, eigenvalue vector only, eigenvalues only, because when you do reduced regularization, it should always be with loss, but this expression is not with loss. So we write wf is equals to y, or we write, yeah, wx, so we multiply wx x transpose is equals to x transpose y, this thing becomes is equals to x transpose y. Okay. Let me just see. So what did you do into this question? Yeah. What did you do in this question? You're not audible. You're not audible. Yes, I can hear you. Yes. No problem. Wait. Yeah, just a second. Please go ahead. Jaya, am I audible? Okay. Just a second. Yeah, please go ahead. Okay, just a second, let me open my iPad. Okay. Okay, Albert is connecting this screen. I'll be sharing it. Let's see if it's possible to share the screen channel. Am I audible? See, let me write it like that. So what I thought, we have to find that value of W, but the question is, I have to find optimal value. Optimal value of W. Where does optimal value exist? On local/global minima. Since this cost function is J is equals to mod 1 by 2 y cap minus y whole square plus 1 by 2 lambda times W square. So this is a square plus square cost function which makes it parabolic, upward parabola, right? This means that its lower bound is here. This means that its local minima and global minima are same. So its optimal value of W lies here. But how do we compute this optimal value of W? We take derivative of this. So we take dou J by dou W. That becomes, what will be dou J by dou W? Anyone? Am I audible? What is dou J by dou W? Okay, let me simplify it for you. Let me write it as XW. Okay. This expression becomes this, okay? Because y cap is simply this thing. Let me rotate it. Y cap is simply this thing only. This is y cap. Y hat or whatever it is. So let me write it. So this becomes 1 by 2 into 2 times. Since I am removing this, let me remove it. Let me write it simply. This becomes xw minus y dot times x. Should it be x transpose? Okay, let me write. So this then next expression becomes 1 by 2 times W, sorry 1 by 2 into 2 into lambda into W. And this thing is equated to 0. Okay. Sorry. This is the derivative, right? This is the derivative. Are you sure this is the derivative, right? No? Okay, got it in there, right? Jaya, did you get it? What is dou of W square by dou W? This becomes 2 times W, right? So this is 2 times W only. I'm removing this. Yeah, I just wrote 2 here just to cut it. Okay, so this becomes xw minus y times x plus W lambda W is equal to 0. Okay. Is it fine till now? This is the correct expression, right? Where's the solution? So what does W become? W becomes something such as sorry. Since let me write this x here. Let me write this x here. Okay. Let me write it as this x transpose x w minus y plus lambda w is equal to 0. Since there are two w's, let me just collapse them. So this becomes x w minus x transpose y plus lambda w is equal to 0. This becomes x plus lambda I times w is equals to x transpose y. Okay, so w becomes x, sorry, this is x transpose x, this can be x transpose, this becomes x transpose x plus lambda I dot x transpose y, this becomes inverse. Am I right? I can solve it again if you did not get it, and I also solve it for the first time. I can solve it again. Shall I do it again? You got it right? Got it right? See, what is... let me show you here. If you see this equation, right, it's given here, equation number 1, w0 plus w1 x1 I plus wm xm I is equals to yi. So for a data point I, it's just product of all the features against all the vectors, all the weights. So in the matrix form it will be written as x cross w or w cross x, right? Got it? So yeah, any other doubts in this question? Yeah. Yes. It's just a simple modulus. It should be a bracket actually. When you apply square over a modulus, if it doesn't matter if like without modulus value is squared and a modulus value squared is the same thing. No. Correct. Modulus is simple dash. Determinants are double dashes. It should have been something similar, different, say L2 normal, L1 normal type of thing. Yeah. Correct. So, any other doubts in question 1? Let's move to question 2. Okay, this deadline is over, right? So why we might resort to numerical methods such as finite difference or automatic differentiation to compute gradients instead of analytical methods. Yes. Oh, sorry. I can only share one screen at a time. So now my iPad screen goes. Now is it visible? So we need numerical methods because like these gradients, we do not have any explicit expressions for them. Like we take a lot of weights, we have to do a lot of computations, but those computations become automatic because we just generalize. We take one differentiation and we generalize over all the weights. Okay, so that becomes automatic. So that's why we have to use this instead of taking analytical methods. So that is the answer of second question. Question 3. Shall I do it for you, or like, do you have any doubts in this question? For question 3. Okay. just use some GPT or use the computer, okay? And then I'll show you. Let me check it. Yeah. Let me check it. Let me do it. It should be 238 only. This much mistake cannot be there in papers. So yeah, it should be 238. The answer given by GPT is GPT visible? Okay, it should not be, cannot be because the screen is different. Okay, anyways, I'll show the answer. The answer is 238.47 given by GPT. Okay, so I'll solve it here. Okay. Again, I have to connect my iPad screen. So just open this tab in your PCs so that you can view the question because it will be gone for you. Okay, is this thing visible? iPad. Okay, so so given data is x. Let me write it as x and let me write it as y. Minus 0.5, minus 0.4, minus 0.3, minus 0.2. This is 48, this is 17, this is 83, this is 19. Correct? So, okay. So let me compute y hat for the order. Y hat is equals to W0 plus W1x, which is W0 is 99.57 plus W1 is 79.28 dot x. Correct? So the value which I have been given here, it's not computed for me. Can anyone solve and give me these values? Let me write it. 99.57 plus 79.28 times minus 0.5. Similarly, this thing times minus 0.4 minus 0.3 minus 0.2. Give me the output. I gave ChatGPT all the options, okay, and what it's telling me, the answer is 238.47, which is closest to 189.5. It's better if you just follow my calculations and see what's the difference in your answer. Okay, let me do it anyways. Where's this GPT now? Is the screen visible? iPad screen. Can anyone solve it? Like what the answers you're getting? Okay, let me read on this screen. 99.57 plus 79. First one. What is first one? Can you write all four values here in chat? Can you write all four values here? So this becomes 59.93, 67.86, 75.79, 83.75. Correct? Okay. So we have to compute our square residual. Square residual is difference, square of difference and summation. Okay. So somebody do this for me. Okay. 48 minus 59.93, 70 minus 67.86, 83 minus 75.79, 90 minus 83.75. What I write all four values in chat. You can omit the negative sign if you want. You have to square it. Residual, square residual. Squared residual error is SR. How did you what is regression error? Yeah, that is what SR is. Just compute it for me. Let's do it here. I'm relying on you guys to just give me correct values, okay? I have uploaded some of them, but I'll upload it today again. Yeah, I'll upload it as PDF only. In front of you, I'll upload it, okay? Just don't worry. No. Yeah, previous assignments I've uploaded. Okay, I don't have solutions of current assignment, so that should be uploaded by professors only. Anyways, now give me the values, guys. Give me the values. What is the output? Shall I solve it? Shall I solve it? Okay, you're saying, okay, let me solve it. 48 minus 59 is 11.93. Correct? Negative. In negative, I'm just writing positive part. This becomes 67.86. This becomes 2.14. This becomes 7.21. Correct? This becomes 6.25. Right? Okay. Can anyone square these values for me? Six 25 is 25 square, 25 to power 4. What is 25 to power 4? First one. 142.32. 4.57. 142 plus 4 is 146 plus 51 is 190. 7 plus 39 is 136. So sorry, 236. So this, I'm just doing rough estimation. Rough estimation gives the answer close to 238. Like point, if you add, it will give you 238.47, right? Something like that. That is the correct answer. Where did you go wrong to get 300 something? Doesn't matter. You square it, the negative part goes away. This is also, yeah, this is y. See, this is y bar. Okay, you did y bar. That is the mean. Okay, you did it for mean. Okay. Yeah. So that is basically, I think that is SST or something. Total. That. Okay. Y hat. So that is. What? Let me just see the formula. What is this? Reverse formula. What are the 4 types of regulars? Let me just check. Correct. No. I'm just seeing what are the formulas. This is my PC screen visible. Okay, let me just see visual formulas. What are those things called? Visual formulas. There are some visuals. Goodness of it. That is R square. Yes. Okay. Okay, something like that. I just hope it has something worth it. Yeah. This is one. This is the thing, right? Yeah. Yeah, but if you use mean, that mean becomes very small. Sorry? Okay, no problem. Do you want me to solve this question as well? Fourth is obviously correct. This one, question number 6. You want to solve it? Let me share my screen. I might not be able to see it. Am I audible? Which notation? I didn't get what notation. Salis is dual error, right? So, some of this dual error. You're still confusing this question. Shall I do it again? Okay. No problem. Question number 6. Do you want me to solve it or like options are significantly flip? And that I told now, more parameters mean more number of fitting problems, so that has high variance. So fitting, last class I told. When debugging learning algorithm, it's useful to plot a learning curve to understand this is a high bias or high variance problem. So learning curve, basically the error curve, it tells you again if you compare validation versus training. If that validation error is high, training error is low, it means it has overfit. If both are low, both are high, it means it has high bias. Okay. So if your algorithm suffers from high bias, only adding more training examples may not improve. Yeah, correct. Just adding training examples may not improve it. You might have to increase the parameters to improve to reduce bias. This question is from last year only. It should be stochastic gradient descent, which we have discussed. Okay, this is optimization with momentum, where a weight rule is given by this. So basically, weight. Sure. Yeah, this one. Yes. So, okay. You take a derivative, okay? You take a derivative of cost function. Getting my point? See, I have to share my iPad again. Just a second. This toggling is the only thing which frustrates me. Just a second, I'll show you mathematically. So let me just show you what is normal weighting distance. So you have a weight W. Wn means mu. Okay. Wo means mole minus some alpha times dou g theta y dou w. Correct? So problem is when we take whole data set at once, full data, for forward pass and do this gives good accuracy. Because you have taken whole data, you have seen whole data, and just to compute slope, you go from here to here. But when you take small batches of data, this reduces accuracy. reduces accuracy means it will toggle between these, like the error just toggles between these bezels. Okay, so if I take some error here, let me just show you like this. So normally this gradient descent, this is higher weight, this is lower weight. Some say this is a, these are 2 points in a convex slope. Okay, got it. Slope means this is a 3D, this is a 3D, this is a 3D loss function. I'm just writing as a 2D so that you can just get it. So you computed loss at once for whole data you got from here to here. But once you do it for small batches, I take small pointer data. So a small amount of data does not represent full data. Okay? Small amount of data, and say stochastic or say mini batch does not represent full data. So this loss will take me here. Okay? For batch 1, L1, then it will take me here, L2, then it will take me here, L3, then it will take me somewhere, it is jumping about. See, it might take me here, it might take me here, it might take me here, and ultimately I will be, this randomness might take me here, in 3D, which is bad. This is L, and after all n data points, this is very bad. Okay? So this happens because I am not following the slope which was given to me in the previous iteration. A new slope is coming up in the new batch, and I'm following that slope, and I'm just moving here and there, here and there, here and there. So that's why we introduce moments. Moments or stochastic gradient descent with momentum. Momentum gives you direction. So see, if you're moving somewhere, like in cricket, okay? In cricket, bowler runs and then he throws the ball. So that bowler is just giving momentum to the ball. He's transferring his body's momentum to the ball, and once that 80 kg, 85 kg human being that transfer momentum to a 152 gram ball, okay, that ball gains a lot of speed. So transfer of momentum gives it speed, weight transfer or whatever it is. So that physics concept is applied here. So what we do is we take previous gradients and we apply to new gradient, so that our losses become somewhat minimized. So you say your initial loss was in this direction. This is your new gradient, dj by dw. Your last iteration's gradient is in this direction. Okay, so your vector sum is giving in this direction. Correct? Sorry, vector sum becomes this direction. Okay. So see, we moved from here to here. We are moving close to this direction, right? So we are reducing the jumps, shifts, and lot of stuff, whatever is happening. Get it? Get a method. You get the vector geometric view of this. Okay. I compute loss in first epoch, that is this. In second epoch, this becomes this, because the batches are small. But what I tell the model is, okay, don't follow this. Take this loss. Take last epoch's loss and add it to yourself, and then take the total summation and move in this direction. Correct? So this basically helps this movements to conserve this direction of your gradient descent. It should not be hopping here and there. It should travel smoothly downwards. So once you add this, this thing becomes very close to this line. Instead of jumping here and here and here, it becomes close to this line. Okay? So that's why we write like this. So initially, you say, last epoch I computed some gradient. Let me write that gradient as delta j old. Now my new gradients are delta j new. Okay? Correct? So after applying moments, my new gradients will be some beta times delta j old plus 1 minus beta times delta j new. Correct? This beta, 1 minus beta basically gives you weightage. So if you take 50% of 7, so if you take 70% of old weightage, you will get 30% of new weightage. So this beta is always, that's why it's kept very small, so that you take small part of old weightage and less part of new weightage. So generally beta is in form the 0.02. like it's kept in this range, 0.05. So you take 5% of this thing and you take 95% of new weights. No, we are taking help from past to help future. It's not technically forecasting future. I told you in the first class, we cannot predict future in machine learning. Okay, this is the old one. This is the last epoch. Okay, this is the last epoch. This is current epoch. Okay, so our updated weight would be weight n would be weight old minus delta J new. But instead of using delta J new, we use VT. Okay. So it dampens, it obviously accelerates convergence by incorporating information from past updates. So that's what we did. We took past updates, we incorporated that information, and we got it here. Okay. Now this is interesting. This is interesting. You are saying something about future gradients, right? See. And then tell me what is different here. Ninth question. These gradients, you see na, these gradients. Okay, what did we do here? We took gradient of WT. See, what did we do here? We subtracted the past gradients from current gradient, current weight. What is this thing? This is simply this equation. This equation is simply this equation. We subtract, we what you see what you are doing. We update the weights. We update the weights as per future as per past. So we take gradients of the new weights which might have been our current weights. Correct? If our assume my gradient is constant. Okay. So my weight updation will be different per epoch. Let me show you. I'm sorry, my screen is not visible. I was showing something. Let me write in the equation and show you. Okay. Sorry. What did we do? Vt is equals to beta times Vt minus 1 plus J Wt minus beta Vt minus 1. Wt plus 1 is equals to Wt minus alpha Vt. What is this thing? This is basically, if I write it here, this is Wt plus 1, this is Wt minus beta times Vt minus 1. Getting it? We are just forget this Vt minus 1. We are taking new weight by using old weight and subtracting old gradient. V is simply your delta J. Delta J after an epoch becomes V. Assume it old. V is a gradient, okay? Delta J is also gradient, del J is also gradient. Past gradient, it is past gradient, but model doesn't know it, right? Model assumes these are future weights. So see this. So let me write this expression here. Vt is equals to B Vt minus 1 plus delta J of Wt plus 1. This is what future gradient. This is future gradient, right? Assume this is constant. You assume this is constant for your for all the parts. Okay. Assume it is constant. So this means what we are doing is we are computing future weights using old gradients, and then we are computing gradients of future weights. This means we are computing future gradients. Okay. Because this equation and this equation is almost same. We are taking current weights only. We are subtracting something from it to compute future weights. Okay, so that's what we are computing future gradients. That is what MAG does, and that is what it's different from standard momentum based gradient descent. Okay. Cool. Now week 4 assignment is done. I will upload a recording today only, and you can watch it. Let's discuss week 5 last year's. Okay. Anybody who has started week 5, submitted week 5? We'll even see questions from week 5 assignment this week. Oh, sorry. Is it visible now? This is like in last year's course. Let me open week 5 material of last year. So this is last year's course, okay? Very boring questions. I mean, these are computation based questions. These are like I like these last questions, na weight based, gradient based questions. These questions are more nice comparatively because they give you intuition of how machine learning works. But anyways, let me discuss this week's questions. Okay, let me discuss some basics of week 5 so that it might help you in completing the assignment. I'm not discussing solutions, but let's see what are some simple questions. Which of the following is not true about sigmoid function? Sigmoid function, from your perspective, what is it like? Okay, from my side it's like this, from your side it should be like this. Okay, between 0 and 1, it lies between 0 and 1. So just another options are for you. Is it linear in nature? Is it differentiable at every point? Is it monotonic? Is it range? Range I have discussed. Just all are options which you have to find out. Okay. Is it monotonic? Is it strictly monotonic? These all things you have to take care of while solving this question. Okay. So can anyone tell me what is the difference between monotonic and strictly monotonic? So what is like? I have this function. Okay, this function from your end. It says y is equal to x. Is it monotonic or is it strictly monotonic? It's both. Yeah, I mean if a function is strictly monotonic, it's monotonic obviously. So it's strictly monotonic. Yeah, Praveen. Praveen, you raised hand. Please wait. Correct. Okay. So what is monotonic means somewhere the slope might become 0 but direction is not changing. That is monotonic. So a step up function is a monotonic function. It's not strictly monotonic, but because at some points the values will become constant. They won't become 0, they won't start decreasing, but they will become constant. So a monotonic function and a strictly monotonic function cannot be loss functions in machine learning, right? Because they don't have a minima. A monotonic function might have some saddle points where the value remains constant, but it starts increasing or decreasing based on the nature of the function. Okay, so that is what you have to take care of while computing deep learning based computation, so that the function is not strictly not monotonic with saddle points, because it might look like the loss has become zero, the gradient has become zero, but loss will not reduce further because we are stuck at that point, because w old is equal w new is equal to w old minus zero. That will, the weights will not change. So that's what you have to take care of. Okay, that's why we use moments. So we take some help from past derivatives. So they basically help in moving from saddle points and jumping here and there. Okay, so that's for another day. But we have to compute. We have to show. Is it monotonic or is it strictly monotonic? That you have to show. Okay. Okay. This is binary constant property. Given the formula, just substitute the values. You will get it. Okay. These are initial weights. This is learning rate, initial weight. Okay. Just compute loss. Feature 1, feature 2, compute loss. Y is equal to W0 plus W1x1 plus W2x2. Should be apply logistic regression, sigmoid over that, and then take log and whatever you want, and then compute loss, BCE loss after you compute it. Okay. So this all you can solve very easy questions. This is some sort of, I think this is x1 or whatever it is. What is it? Okay, whatever it is. Sorry, yeah. One upon 1 plus e to the power minus x y z, whatever it is. Okay. You are asking for this question, right? Okay, let me write it. I will not compute the solution, I will just show you the formula. Is this screen visible? The part screen? Okay. So you will have two features, x1 and x2. Okay. So for linear regression, your y is w0 plus w1 x1 plus w2 x2. We have been given initial weights as 0, 0, 0. That's why I assume there is a bias weight as well. So bias is 0. This is w0. This is w1. This is w2. For logistic regression, we apply sigmoid over this. Okay, so this becomes 1 by 1 plus e to the power minus times w0 plus w1 x1 plus w2 x2. Correct? This gives you a value in some certain range. That range is, let me write a comma b, which is constant for all values, because I am not writing exact range because you are solving it here. Okay. Now what you have to do is, since you have computed y, you take loss. Your loss is y minus y cap. This is y cap. Your y is 1, 0, 1, 0. Okay. But we don't use this type of loss in logistic regression. We use BCE loss. Okay. So your BCE loss is y of log of, this becomes something y hat plus 1 minus y log of 1 minus y. Okay, we do this, we compute BCE loss for iteration 1. Okay, then you take derivative of this loss, dou b1 by dou w, we take it for w. Okay, so we compute this thing and then we change weight. W0 is equals to W0 minus dou V1 by dou W0. We do it for all the losses. Okay, we do it for all the weights. We compute final weights. So iteration 1 is complete. Then you again do it. Again you do it W0 plus W1 x1 plus W2 x2 sigmoid. You get y hat. Okay. Then you compute BCE loss. Okay. So this is what you have to compute after iteration 1. Okay. This should be some value in this range in these options. Got it? Yeah, you can just write code as well. Writing code would be much better. I mean, I wrote the code in last class. You can just copy paste it. Just change the log loss and etc. And use it. I have put in the code there as well. In that Google Drive. Just a second. Okay. So any doubts still here? Any other question? Yeah, this is, I mean, you have the more the merrier data. The point of data is more the merrier. Less data, you might overfit, and you will overfit because you don't have data. I mean, if I tell you, I have a, actually you might get biased predictions. You might overfit if you have a lot of parameters and very less data, then you might overfit. But if you have very less data and training, so you will get biased predictions. So let me tell you. I have x is equal to 2, y is equal to 4, I have x is equal to 3, y is equal to 7. What kind of equation can you make from this? X is equal to 2, y is equal to 4, x is equal to 3, y is equal to 7. What kind of equation can you make from this? You can make quadratic and you can actually plot a linear equation as well. It's not, there are 2 points in space. You can just draw a line between them, that will be your equation. But the thing is, that's your assumption. Very less data. That you assume this is the correct answer. See, you assumed a quadratic equation, I assumed a linear equation. That was our bias. Because we did not say the full data. Okay? Got it? No. There is no thumb rule, but I mean it depends on the domain experts. Like if you are expert in a domain, you might be able to solve the problem using 100 data points. Okay, but I might not be able to solve it using 5,000 data points. So that's up to you. It's very like it's not even a rule of thumb. It depends on case to case. Okay. Impossible. I mean, 4 to 5 data points are very less. A machine learning algorithms to fit 4 to 5 data points are very less. Okay. So yeah, anyways, I mean, this is out of scope for us. I mean, I cannot help with that because I have no experience in that. So, at least for me, it is out of scope. So yeah, anyways, what other doubts people have having? Let's discuss those doubts. I mean, the questions are very simple. Like they are very value putting questions. I mean, solutions. You just implement the code. Try implementing the code for it and try solving it. You might get the solution. Okay. Let's go to last year's week 5 assignment. It's also quite similar. This question is very simple. Just try solving it. I'll share this week 5. Okay, I'll share this week 5 question paper solution and solution with you. I have solutions with me here. Okay, you can go through it. See, ultimately they have also written the code. Okay. Oh, sorry. Unfortunate incidents. Is it visible now? So if you see now, this questions and solutions are given here. I will upload it right now. Okay, it has been uploaded. So you can go through it. Not very difficult to grasp. I mean, these are just very basic questions. You can just write code like they're written here and you can just solve it. Okay. There's nothing to be discussed here. They have also written this code. There are competition heavy assignments. I don't think so you need my help in solving this. Try solving it once. If you're not able to solve it, then we can discuss it again. Some of the theoretical questions I would like to discuss here. Why is a linear model alone insufficient for logistic regression tasks and then acceptable classification tasks? Okay. So we know that linear models predict value regressively. I mean, they can exponentially increase, they can decrease within infinite. Their range is from infinity to minus infinity to plus infinity. But for logistic regression, we need probabilistic tasks. Okay, we need to convert to probability. Okay, so that's why we have to restrict the output between 0 and 1. Either it belongs to this class or not. Okay, so they are not unable to understand that's complex. I mean, the data is linearly separable, so relationships are not that much complex. Okay, so they are able to understand. They cannot guarantee the output will be corresponding there. Because they cannot guarantee. Ultimately, they cannot guarantee because their range is from minus infinity to plus infinity. They are not computationally expensive because they are just logistic models are extension of linear models. So how can linear models be expensive? It's not like they require large data sets. They can be spread on same data sets. So this option is correct. And for rest of the questions, just try solving it. Manually. I can solve it. Okay, just wait a second. Question number 5. Let's do question number 5. Question number 5. Can anyone read it? Correct. So just leave it up. I'll leave the options. Okay, just leave it. Okay, so one hot encoding means you might have studied it. Just leave it. I'm not teaching that. So since retirement is given, so retirement will become 1, others will become 0. Okay. Had it been investment, this would have been the correct answer. Had it been savings, this would have been the correct answer. Okay. Single column represents retirement. We cannot create single column, otherwise it would not be one hot encoding. Since currently there are 4 categories, and 4 categories can be handled simply. I mean, they don't even require one hot encoding. But had it been 20 categories or something, then we would have required one hot encoding, and that's why this is used. Okay, so correct answer will be retirement 1, others will be 0. Rest of the questions are very basic, computation heavy questions. Okay, so do you guys have any other doubts in week 5 or week 4 or whatever doubts you might have? Do you want me to write some coding to solve that? Okay, let me show you how to compute log loss. Okay, I will use Gemini to write the code, but I'll explain the code to you. This code might be useful when you are computing binary cross entropy loss, etc., etc. This is week 5. Yeah, please. Please go ahead. Yeah, they are quite same. They are actually same. I would not say they are not same. But what is log loss? You take log of 2 values, I compute. But got it? I take log of 2 values and I compute loss. That is log loss. Got it, right? Okay. Why do we compute binary cross entropy loss or whatever we call log loss? And why don't we compute that simple mean square error in logistic regression? Because we are computing probability. Okay, hear me out. We are computing probability. If we subtract probability from say 1, 0, I will have some label and I try reducing it. So that creates problem. Why? This computation, this does not remain complex. This does not remain concave. Okay, that becomes something sort of step up, step down, monotonically increasing, decreasing, anything. It might have multiple minimas, multiple maximas. Okay, so that's why we don't use mean square errors in logistic regression. That's why we use binary cross entropy errors. Got it? Okay, so let me just show you. This is week 5, right? Week 5. CS. Okay. Take a sample data set for logistic regression. Take some random compute logistic regression outputs and then compute BCE rules. Don't use libraries. See, I told it to write simple, but it has written a lot of complicated code. Anyways, let me show you. So, I import math library because sigmoid, exponential, etc., they lie in this. So this is what sigmoid is. Sigmoid is 1 by 1 plus exponentiation of some value z. Okay, let me write this logistic prediction. It has been written in loop, but I'll write it as simply as like so. This is bias term. For all other features, we take I plus 1 weight, we multiply feature, and then we add it to it. So this gives you sigmoid. Is it understandable, or should I write it simply? Let me write it simply. Let me write weight 0, weight 1, weight 2. Okay. So this gives me weight 0 plus weight 1 into features of 0 plus weight 2 into features of 1. Okay, return sigmoid of 0. Now we have, let's take this and we'll write binary concentric separate later on. This is our data. So if I print data set, it will give me this. So for feature 1 and feature 2, this thing output is 0. For this is this, this is this. Okay. Now these are the weights. These are some initial weights. Okay. Let me compute logistic regression. Logistic regression predict. This is the function, right? We pass weights of 0, weights of 1, weights of 2. Okay. Sorry. Then we take data set. Okay. Let me write it in loop format, but it's written here. Let's compute loss, etc. Loss is written here. Okay. Let me print features. And let me print target. Okay. So we will pass these features as it is. So we'll pass these features as it is. We take prediction. Let me take prediction. Right? Prediction. So okay, so these are the predictions. This is close to 0.5 because the weights are not optimized. So this is giving me a random probability. Okay, has again something. Okay, sigmoid has been applied. I'm not applying this thing. This is unnecessary for us right now. So these are the predictions, right? Okay, sorry, no. So loss is binary cross entropy loss. Let me compute loss. Loss is binary cross entropy loss. Let me write the function here. Am I audible? I just thought my internet has gone like disconnected, but and I'm just speaking. Okay. So we take loss, we apply binary cross entropy. Let me just remove this thing. Let me just keep it simple. Okay. So we take y2, mat.log, y pred, 1 minus y2, mat.log, 1 minus y pred. We return negative of it. This is binary cross entropy. We compute binary cross entropy loss. Okay, let me just print loss as well. So for this data, this was the loss. For this data, this was the loss. Okay. So total loss becomes this thing, and let me write it like this one. Okay, for these features, these are the losses. Average loss is divided by this, so this is how we compute the loss. Okay, got it? it right. Yeah, keep on practicing. Next thing what you have to do is, you have to take derivative of this loss, you have to compute gradients, you have to subtract from weights, and then ultimately what you will get is updated weights and updated binding cross entropy loss. So I will upload this notebook, take help of this notebook and last week's notebook, and you will be able to solve the gradient descent part as well. Putting it here. Okay. So yeah, any other doubts in any of the question assignment, whatever? No doubts. I have provided the assignment files here. I have just shown this this Excel sheet. Okay, whatever program I write, it's uploaded here only. This sheet is shared to you in the announcement section every week. Look at this sheet. Okay, they send it. This is, if you know where you will see the sheet. This is last year's, I think. Okay, so they upload the sheet here. No, I got it. This is last year's course. You will, in announcement, you will be able to find sheet, and you will be able to find this Excel sheet there, and you will be able to access this repository. Okay. For detailed solutions of all questions, you have to ask the instructor. You have to mail the instructor and they will provide the solutions for you. I cannot provide it because I don't have the exact solutions. I can help you solve the questions here, but I cannot make the solutions. The instructor has the exact solutions for it. See, I make some solution, some answers come different with what I compute and what professor has given, so that creates problem. So that's why. Any other doubts? Please say guys if you have any doubts, please say. Okay, no problem. So I think we should end the session for today here only, and let's meet next week, Friday. That will be 1st of March, I guess. Okay, I have to email NPTEL team that I will email it after some time, but I will not be able to take 15th March session. Just 14th is only, 14th March is only. Yeah, okay, okay, yeah, okay, okay. That's somebody. No problem. I will email NPTEL. Okay. Thanks a lot, guys. You can drop. Let's meet next week. Take care. Have a happy weekend. Yeah, Miriam. Okay. Thanks a lot, guys. Bye bye.